Hello, my dear students. I hope you are doing great. So here I have uploaded a very nice question in physicsma.com in JEE Advanced section practice problems. So you can practice a lot of problems, very nice problems I have uploaded. Okay, and you can see this problem over here. So I have this problem. I will be studying this problem and we will be solving it. Okay. So first, let me tell you about the feature. So like here you can see that this problem is from the rotational motion medium level problem, and the topics are translational equilibrium plus rotational equilibrium plus we can say the equilibrium of a rigid body. Okay, and now here we have the four options, and then I have given rough work here, the whiteboard on which you can do your rough work. Okay, and finally submit the answer. And after submitting, after submitting that, all your work is going to be saved. Fine. So work is going to be saved. Let me submit that. I know the answer is here. This is the answer. So if I submit it, you see the correct plus 4 marks, and then the solution I have uploaded here, all step by step, very nice way. All the steps I have included here, and then everything in the diagram I have shown. Okay, and you see all the details I have shown. Moreover, this is for the general case, for the special cases and standard applications. Also, these results are true. So you can remember this result directly. Okay, and then when you go to my desk, okay, and then you can see a lot of things over here. Lot of features I have included. Okay, like preparing for which one, ITJ main only or ITJ main plus advanced, like that. So accordingly, you see here a lot of things I have included. I will be discussing all these things step by step, but right now I have the rank accelerator, then the practice board on which you can practice all your questions. Okay, and here in J Advanced track, so the lectures and the practice problems I have uploaded. So I keep on uploading the problems. So very important one. Well, and then here your result will be shown like this. This is my personal account. Okay, just I'm testing this. So all your result is going to be shared. Look at this, all your result. So here, this is view my work. You can view your work also. For example, this is wrong. Okay, so you can view your work. Whatever you are writing on the whiteboard, it is going to be, you can see here. Okay, right now there is nothing to be shown because no work was there. Otherwise, you can see all your work, and then at the same time, you can share it to the forum. If you are sharing this question on the forum, look at this. Look at this here. This right now you are on the forum. So someone, either me or your peers, is going to reply to your question. Okay, and your work as well is going to be shared. For example, anyone can reply over here. Okay, like that, and the whiteboard, everything is there, and then post a reply. So this is the basic thing which I have implemented. Moreover, going forward, I am going to implement something like AI analysis based on your whatever you are thinking. AI is going to analyze your thinking process. This is not the current feature. Going forward, I will be implementing. So right now, let's discuss the problem which we were doing. Okay. So we were doing this problem. Let me go to the JEE Advanced section. So here I am going to the practice for JEE Advanced practice, and this problem is in a rotational motion. So very nice approach you will be getting here. Okay, so keep practicing. Everything is free. Now you just practice, and then whatever you are getting, if it's wrong, you can share it to the forum as well, so that I can reply or any of your peers can reply. So let me see here, medium, this problem we are discussing about. So here the question says that a symmetrical rigid body with a flat base of length L is placed such that one end of its base rests on a rough horizontal floor and the other end rests against a smooth vertical wall. So you can see here this wall is smooth and this floor is rough. Okay, the base of the body makes an angle theta here with the horizontal by the if the center of mass of the body is located on its axis of symmetry. So here this is a symmetrical body, you can see, and this is the axis of symmetry, and center of mass is lying here, and it's lying at a perpendicular distance ycm from the center of its base. So this is the base of length L, and from the center of this base, perpendicular distance, this is perpendicular one. From this is YCM. What is the minimum coefficient of static friction mu required between the floor and the body to prevent it from slipping? So we have to avoid slipping. So what should be the minimum value of mu so that this body does not slip? So let's solve this question over here. Okay. So now you see that let's discuss about the solution. So we know this is going to be the answer, and so I'm going to check answer. So you see here what I'm doing it here. So first of all, you have to draw the FBD of this body, right? This is a symmetric body. So one is this mg force and the normal reaction force offered by the rough floor, and NW is the normal reaction by the wall in this direction, horizontal direction. And by the way, this is smooth, no friction will be there, and there is one friction force. Okay, and this body has the tendency to slip in which direction? In the right direction. So to the left, friction is going to act. So this is the free body diagram. Okay, so then we have to balance the forces for translational equilibrium. So in the vertical direction, normal is balancing mg, n is mg, and in the horizontal direction, NW is balancing the friction. So NW is balancing the friction over here. Okay. So now we have got the translational equilibrium, and the next one is going to be the geometry of the center of mass. So because we are going to make use of x, what is this value of x? So later on, first of all, let's find out this value of x using this geometry. So you see that this is the point center of mass, and this is your YCM distance, right? And this angle is theta, so alternate angle, this angle is also theta, this will be 90 minus theta, this angle is going to be theta, right? So now from here to here, this distance is going to be YCM sine theta, right? And in this right angle triangle, and in this right angle triangle, you can see that this distance is L by 2. So this angle is theta, it's going to be L by 2 cos theta. So L by 2 cos theta minus YCM sine theta, right, is going to be what? This distance, which is x. And x is the horizontal distance of the center of mass from point A. This point A is the contact point between the body and the floor. So we got the value of x. Then we have the torque equilibrium, means the rotational equilibrium, right? So what I'm going to do is to get the net torque about the ground contact point E. This point, about point E, we are going to make net torque equal to 0. So about this, why we are taking up this point? Because you see the friction and this normal is going, torque of this is going to be 0. Okay, torque of these two forces will be 0. So the torque of mg is going to be mg into x, right? Torque of this gravity. And if you curl your fingers, then the direction of this torque will be out of the plane. Okay, and torque of this NW, this one, NW, about A, is going to be NW into the perpendicular distance. And this perpendicular distance is going to be this distance, which is L sine theta. So NW into L sine theta, torque of NW is equal to mg into x, and the value of x we have already calculated. L by 2 cos theta minus YCM sine theta. So if you put, so you are getting NW, and L, by the way, will be out, and then you will be getting mg into cos theta by sine theta. You can bring this to the right side, right hand side. So it will become cot theta by 2 minus YCM by L sine theta get cut. So now for the body to remain in equilibrium, we can also say that force of friction must be less than equal to the maximum static friction, which is mu n. And from the translational equilibrium, we have F is equal to NW, as we have seen, and N is equal to mg. So putting these values, friction is NW we have already calculated, right? So F is NW, which is equal to this one, less than equal to mu into the normal. Normal is mg, and if we do, mg will be out, and mu is greater than equal to, we will be getting cot theta by 2 minus YCM by L. That's it. Okay, this is very interesting result. You have to remember this result, and that's the minimum required coefficient of friction. Cot theta by 2 minus YCM by L. Okay, remember this result, because this result is going to be applied for many standard cases. You see, for the uniform rod, thin rod, we have YCM is 0, right? Because this perpendicular distance will be 0. So mu minimum will be cot theta by 2. We know this result. Mu minimum is cot theta by 2. Similarly, if it is the semicircular wire, right? Semicircular wire like this. So in this case, you can directly have L is equal to 2R, YCM is 2R by pi. We know for semi 2R by pi. And length L is, this length will be 2R. So mu mean accordingly will be getting. So similarly for this, 4R by 3 pi. For this YCM we know, hollow hemisphere we know is R by 2. Solid hemisphere we know 3R by 8, YCM is 3R by 8. Accordingly, like for the triangular lamina with base L and height H, we know YCM is H by 3, right? So this is standard, pretty interesting result. Remember that. So going forward, we will be using this way only, and I urge all the students to practice these problems which I am uploading over here. Okay, so keep on doing it. See you in the next video.